Hello everyone. Today we are going to talk about how graphic card actually work and which one you should buy. Well, every graphic card review tells you the same thing. Like if you have more cores, it will have more speed. You should buy this. That's maybe 20% of the real story. Well, I am a computer architecture researcher. Let me give you the other 80% and then you should decide which graphic card to buy for gaming or machine learning. Well, to understand this, you need to understand what actually GPU is. So the GPU is the main chip on your graphic card. Here what it does, like for example, a CPU handles one complex task at a time very fast. Similarly, the GPU on your graphic card handles thousands of simple tasks at the same time. That's the core difference between GPU and CPU. Now, in gaming, you need millions of pixels calculated on every frame, each one independently. Similarly, machine learning needs millions of matrix operation, each one independent. So both problem is split perfectly across thousands of GPU cores running in parallel. That's why graphic cards dominated in both the fields. Now, here what actually decide if your graphic card is fast or slow, and nobody usually talks about this. It's not about core count. You need to understand it's not about the core count. It's about the memory bandwidth, and the VRAM. Now, what is memory bandwidth? Well, it is how fast data reaches the GPU cores on your graphic card. You can have 16,000 cores, but if the data can't reach them fast enough, most of them sit idle doing nothing. This is why two graphic cards with the similar core counts perform completely different. One fits its cores faster, the other doesn't. Now, VRAM is how much memory your graphic card has on board. For gamers, like that means textures and frame buffers. For machine learning engineers, that means your entire model, gradients, and optimizer states, all loaded simultaneously. And in case, like suppose if you are run out of VRAM while gaming, you get the frame drops. Running out of machine learning, the job crashes and it will impact your whole training. So which graphic card actually you should buy? If you're gaming at 1080 pixel on a budget, Intel Arc V580 or NVIDIA G4 RTX 4060. Both are handling 1080 pixel easily. The RTX 4060 gives you DLSS, NVIDIA's AI upscaling, a real performance boost in the supported games. Anyone now telling you to spend more on 1080 pixel gaming is selling you something. So be precautious. Now, if you're gaming at 4040 pixel or higher, AMD Radeon RX 9070 XT or NVIDIA G4 RTX 5070. Here, AMD gives you the better raw performance per dollar. NVIDIA wins on the ray tracing and DLSS. Big based on which features you actually use, not on the brand loyalty. So think that what you want. If you are a student, you are starting the machine learning, NVIDIA G4 RTX 3060 with 12 GB VRAMs, older graphic card, cheap and 12 GB enough to learn experiments. That is not a harm. And building a real projects, you do not need to spend 4,000 euros on a graphic card to start learning machine learning. That's marketing, that's not engineering. Now, if you're doing a serious machine learning work, NVIDIA G4 RTX 4090 with 24 GB VRAM, best single graphic card option for local training. It handles fine tuning 70 to 30 million parameters. It's that's out of budget. In that case, you can use Google Colab or RunPod for heavily jobs and keep a cheaper graphic card locally for quick experiments. Now, if you have less budget, in that case, and you want to train an ML model, in that case, Google Collabs give you a free GPU access in the cloud. You start there, buy a graphic card when you hit a real limit, not before. One more thing nobody tells you, honestly, last generation mid-range graphic card does also do the same thing as this generation budget card on a less money. Like use RTX 3060 12 GB for ML, use Radeon RX 6800 XT for 1440 gaming. These graphic card is still working. Here physics didn't change, the silicon didn't expire. The GPU industry wants actually you on a yearly upgrade cycle. That's engineering said that you do not need one. So think before buying. So remember three things. First, can your workload run in parallel? If yes, a graphic cards help. Second, do you have enough VRAM? This is the matter more than a core count. Third, is your memory bandwidth fast enough to keep the course busy? Answer those three questions for your use case and you will buy never the wrong graphic card. So this is how all about today's video. Hope you understand. And if you like this video, you can comment on my comment section. And thank you so much for watching this video.